Hi everyone, welcome to today's webinar, Engineering Creativity. My name is Katie, I'm the Communications Manager here at Vitech, and I will be your host during today's webinar presented by Zane Scott. Zane is our Vice President of Professional Services and our training organization here at Vitech. For the past 25 years, he has built a skill set which enables him to provide insight and guidance to individuals and companies as they improve organizational processes and methodologies across their organizations. He has taught systems engineering methodology in the practical process context in a variety of settings. Zane has a BA in economics from Virginia Tech and a JD from the University of Tennessee Law School. He has completed his postgraduate work in business administration and educational counseling. Zane is a member of the American Society of Training and Development and the International Association of Hostage Negotiators. Before Zane gets started today, I do have just a few housekeeping items. We will be answering questions at the end of the webinar, so please send your questions in as soon as you think of them through the question tab on your webinar control panel. Zane will answer as many questions as he can today, but if we can't get to your question, we will reach out to you after the webinar. The webinar is being recorded today, so if you do experience any connection problems during the live presentation, a recording will be available by request, or actually on our website, I apologize, on our webinar archive. I'll send out a link in just a moment through the chat window so that you can have that ready. I'm now going to turn the presentation over to Zane. Welcome and thank you for joining us.
Thanks, Katie, and welcome everybody. We appreciate you taking time out of what I know is a busy day for all of us to be with us for the next hour or so, and I want to make you welcome to this particular webinar. This is a subject that I find very interesting and a subject that I see increasing importance in the area of our systems engineering practice. The title is an intentional double entendre. Engineering creativity refers to the creativity of engineering. So engineering can act as an adjective in talking about the particular kind of creativity that we're going to talk about today. But it also means that we can engineer the process of creativity. Lots of times people make a mistake, and when you say the word creativity, or you talk about somebody being creative, or you talk about a creative work, we tend to get a vision of a genius kind of behind the curtain, like the Wizard of Oz, who is able to pull some levers and things happen in a flash. And that's not how creativity works. Creativity is a process, and it can be defined, it can be improved, and it can be practiced intentionally. And that's really the subject of our webinar today. So I thank you for joining us, and let's get started. The first thing that I want to talk about is to say that we're going to deal with a timeline that runs from experiencing the problem and deciding to solve it over on the left side across time to the arrival at a solution. We see that in our everyday lives. We get problems sent our way to be solved, and what we have to do is to move from the problem to the solution. Now, in order to do that, we go through a number of steps. Sometimes we don't go through these steps intentionally, and sometimes we don't go through them consciously. We may actually jump them, but they happen. And our choice is whether we can make them happen in a way that suits our purposes, or we can simply let them happen to us. So we begin with the phase where we understand the problem. You can't solve a problem that you don't understand. And how well you understand the problem influences the quality of the solution that you'll arrive at eventually. Once we understand the problem, then we begin to create choices. Now, hopefully, especially after today, we'll all create choices intentionally, and we'll think about the way in which we create choices. But we create choices, and we either do that quickly, we can do that sloppily, or we can do it intentionally. we can give it the time it deserves. And that's some of what we'll be talking about today, is this process of creating choices. Once we create those choices, they become alternatives from which ultimately we can select a solution and then refine the choice that we make. And those are the two final stages. We have a menu of choices, if you will, that we have created, and then we begin to select from that menu to choose, and then we begin, once we choose ultimately one solution, we'll refine that out to implementation. So we're going to talk about that process today. Now, I want to say a word about the relative importance of understanding the problem. Einstein said if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about solutions. That's probably way more than we would allocate to that, but that is excellent advice, and that's probably appropriate. It's certainly appropriate advice in a society where we are tended to focus on the end stages of choosing a solution and refining it. And we'll talk about how we're slanted toward that. But Einstein said that we ought to allocate 55-5 toward understanding the problem and ultimately making our choice and thinking about the solution. Now, as we begin that, having said that, we're going to make an assumption here, because understanding the problem is a subject for another day. That's really not what we're talking about today. So we're going to begin with an assumption, and our assumption is that we understand the problem. So we're going to begin by saying we've done our due diligence, we understand the problem, and we'll skip over that and begin our discussion of creativity with the creation of choices. Now, over and over again, you're going to hear me refer to models and modeling and using models, and I'm also making the assumption that we are availing ourselves of the advantages of models. We could spend a whole webinar, we could spend the rest of the day, we could spend the rest of the week talking about the importance and uses of models. Models are a thinking tool, and models are a way for us to make relationships and elements and our assumptions about the problem and the solution visible for everyone. And by doing so, that promotes communication and promotes collaboration. So we're going to assume that everywhere it's appropriate, we're going to avail ourselves of that aid to our thinking. So the first concept that we're going to encounter here is that we're going to talk about two kinds of thinking, and this is going to be very important to our discussion. The first kind of thinking is divergent thinking, and the second kind of thinking is convergent thinking. Divergent thinking is the process of creating the choices, of coming up with what the potential options are for creating solutions. The convergent side and method of thinking is the way in which we converge ultimately on a solution. It's the kind of thinking that we use to make the choices from among the menu that we've created. Now, there's a concept here that is obvious when we think about this, but is forgotten a lot of the time in our problem solving, and that is that the more options we have when we begin the convergent phase, the better the quality of our ultimate solution is going to be. We have a tendency, and we'll talk about this tendency, to jump to solution, to move quickly towards solution. So we want to jump to the convergent kind of thinking as quickly as we possibly can. And when we do that, we cheat ourselves, because it's during the divergent phase that we create the choices. We create the menu from which we're going to choose. So we're more likely, just as in a restaurant that has lots of choices, we're more likely to be able to find something that's suitable as a solution than if we had few choices. Now, lots of times this is an opportunity cost, so it doesn't become apparent to us. We say, well, what about this? I came up with this solution and it's perfectly fine, and I only had 3 options to pick from, and et cetera, et cetera. Well, the way to think about it is that if you didn't have the large menu, you don't know what the ultimate solution might have been, because what you're costing yourself is an opportunity. So we're not generally able to see lost opportunities because we never went there in the first place. So when we fail to engage in divergent thinking, we don't, on reflection, catch that that's a problem unless we understand the importance of divergent thinking to our creative process. So we need to learn to engage in both divergent and convergent thinking. Now, fewer choices are going to result in lower solution quality, and more choices are going to result in higher solution quality. But we have 2 problems with that typically. The divergent thinking stage gets short shrift. It gets shortchanged in 2 primary categories of ways. The first thing is that we're actually schooled to make choices, but we're not schooled in how to create choices. Our whole education, both socially and culturally, and the intentional part of our education in the education system, is almost designed to beat the creativity out of us. And by that I mean beat the divergent thinking out of us. If you want to hear some interesting discussion of that, there's a fellow named Sir Ken Robinson who has some very interesting TED Talks. And if you've been in my webinars before, or you get to know me, you'll come to know that TED Talks are one of my favorite sources of knowledge and entertainment and broadening my own thinking. But Sir Ken Robinson talks about how divergent thinking, creativity, is almost schooled out of us, and we lose the inclination to do that. So we tend to shortchange it. In addition, when we do use the divergent thinking process, we tend to pollute it with convergent thinking. So we tend to limit it by making judgments. We begin to make choices. Somebody has an idea and somebody else says, nah, that would never work. We need to not consider that one. Anybody who's ever been through a brainstorming process or received some instruction in brainstorming, one of the things that you're told to do is to refrain from making judgments. And the reason that you're told that is not so much that a particular idea might wind up being the solution and you're tempted to throw it out at this point, although that's possible. The bigger danger is that when you kill that idea, you kill its children as well. So having an idea on the table may spark someone else to say, oh, well, yes, I couldn't do that exactly, I could do this, and it sparks the creativity that allows the thinking to really diverge. And so that's why, for instance, in classic brainstorming, one of the rules is don't make judgments. In other words, don't engage in convergent thinking too early. But we tend to shortchange the divergent process because it's been schooled out of us. we're better at convergent thinking, we're more inclined to convergent thinking, and that even causes us to pollute our divergent thinking with convergent behaviors. The other thing is we're tempted by education, by bias, to jump to solution. So it gets very, very tempting to shortchange the whole process by saying, I've seen a workable solution. I have an idea. This is a good idea. We could really do this, and jump right on it and start refining the idea. And so we have a tendency to leap to solution. One of the things we're going to talk about is the number of ideas that we entertain, the number of ideas that are under consideration for us across this time frame that we set up. So as we begin to get into problem solving in the divergent stage, the number of ideas begins to increase. And remember, keep in mind the basic formula here is that the more ideas that we can consider, the higher quality solution that we have in terms of potential before us. So our ideas will increase, the number of possible choices will increase until we begin the convergent phase, and then we'll begin to eliminate them as we start to converge on the solution. So how do we raise that peak? How do we improve the quality of our ultimate solution by raising that peak? Well, of course, there's two ways that would be obvious. And my mom was a math teacher and taught geometry and calculus, so she would be disappointed if I didn't point these two out. One is that we can make a steeper slope. We can add choices more rapidly during the time period that we have allocated to divergent thinking. And we do that by making our process better, making it more productive. We keep judgment, we keep convergent thinking out of it. We use tools, we might use common brainstorming, and we would try to avoid the temptation to judge. I'm going to suggest to you a couple of resources, a Thinker's Toolkit and a book called Thinker Toys, which have a number of strategies for doing this kind of thinking with our creative process. But keeping the judgment out is a difficult thing to do, to keep from running the two phases together. And so, for instance, with brainstorming, it's so tempting to do that lots of folks choose to use a technique called brain writing, which is brainstorming, but you don't put the ideas out to the group right away. So you don't open it up for group comment, which means that you don't have the temptation there for somebody to jump to judgment. But using brainstorming, brain writing, other techniques steepen that slope and give us more choices. And obviously, the other thing that we could do is we could extend the amount of time that we give to divergent thinking. We tend to limit it. We tend to try to get out of that and get into convergent thinking where we're more comfortable. But we can raise the peak by extending the time, by doing both things, by making a better process for ourselves in the divergent thinking process, and by extending the window in which we use that, we can create more choices and improve the quality of our solution. So, not cutting off the divergent phase can be an important technique to use. Now, if you're going to use that technique, one thing I would say to you after having facilitated a number of these processes is don't be afraid of silence. You know, often we say, okay, we're going to engage in brainstorming, give the brainstorming rules, and we say, now, does anybody have an idea? And we have several ideas that go up on the board, and then there's a period of silence, and we get uncomfortable when that happens, and so somebody says, okay, now that we got our ideas, let's start to evaluate them. And we move into the convergent phase. Don't be afraid of that silence. Let it percolate. and use multiple techniques. We had a good example here where we were trying to solve a problem, and so we needed a number of alternatives to consider, and we had basically done classic brainstorming and had about 20 ideas, and we were out. We were just dry, no more ideas. So actually what we did was we backed up and we engaged in the brainwriting, and by the time we were finished with the brainwriting technique, we had 97 ideas. I was tracking, I was hoping we'd get to about 5 times, and we did. We got 5 times as many potential choices to feed our convergent process. So don't fear the silence and don't end too early. Make your process better and extend the amount of time that we're willing to engage it. Now we have some creativity killers that we have to deal with. One is that even over in the convergent stage, we tend to rush that. So it's not a smooth slope down the making of choices. We rush it by rushing to solution. So we spot things that we think ought to be a part of the solution, and what we do is we'll make some kind of a decision and use that to lop off a bunch of ideas. So instead of coming down smoothly and considering things one at a time, we're chopping off groups of things, and so it becomes more of a step function down to the potential solution that we're going to work on. We rush to solution. Why? Because we don't want to engage in this process more than spend more time, more money, etc., investigating these choices. We need to get to the answer. And we have a kind of a there's a right answer mentality about it as well. But as we go along, we identify things and we jump to it. Sherlock Holmes, or I guess Sir Arthur Conan Doyle through Sherlock Holmes, said it's a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. In other words, when you get into this process and you begin to develop a theory, then you're going to abandon ship on other alternatives that might be there. I used to do some teaching in a law enforcement academy, and one of the courses that I taught was a course on evidence. We would set up a crime scene for the students. And as an experiment, we'd divide the class into 2 groups, and we would brief them differently. The first group we briefed with an explanation of what they were about to see, plus the beginnings of a hypothesis about what had gone on. The second group, we would brief them on what they were about to see, but gave them no hypothesis to work from. The group that went in with a hypothesis always came out with a different report of the evidence that was in the room from the report that was given from the group that was given no hypothesis. And the difference there, interestingly enough, was that we had planted in the room, and they both looked at the same room in the same state. We had planted in the room some pieces of evidence that ran counter to the hypothesis we gave the first group. So when they came out, invariably, they did not report the presence of that evidence. It wasn't that they reported it and explained it away in light of the hypothesis. They didn't see it. And in fact, on a couple of occasions when we ran that, they would get into arguments with the second group. The second group would report that that evidence was there. So it would be in their report, but not in the report of the group with a hypothesis. Why? Because the cognitive bias, the brain process there, can actually cause us not to see things that are inconsistent with our hypothesis. And that impacts, of course, the quality of our ultimate solution. And that's the bias operation that goes on when we get into this step function drop-off kind of jumping to solution. So sunk cost bias, we've got a group working on this, and they've already gone in that direction, and we don't want to lose what we've invested in that particular solution. The confirmation bias, that you tend to see things that confirm where you think you're headed and not see things that are disconfirming. So all of your cognitive biases can come into play to cause you to jump to solution, which is something that we're naturally tempted to do anyway. Another creativity killer for systems engineers, and I'm amazed at where all I've heard this statement made, but I've been told by very senior people in companies engaged in large projects, we allocate requirements directly to components. We don't fool around with that behavior stuff. We don't mess with that. Now consider, this is our classic systems engineering schema. We have requirements, which are the basis of behavior, which is allocated to components. The components perform a behavior, and the behavior is based on the requirements. So if you have a sound design, your requirements are fulfilled by the behavior, and the behavior is performed by the components. So you don't really allocate requirements directly to components. Now what's advocated is that we just skip by it. We don't fool with that behavior stuff. You don't do a functional analysis, for instance. You just simply allocate your requirements to particular components. Why is that a problem, and what does that have to do with creativity? Well, the problem that comes up when we take that view is that it acts to cut off choices. Now, it can even dramatically, when we jump to a particular solution, it can truncate it completely so that it's not a step function, it's a cliff function. But even at best, as we choose individual components along the way, it drops. And it drops off because two things happen. One is that when requirements become the basis of behavior at a high level, then we have several ways that we could break that behavior down. So there are different ways to accomplish a particular high-level behavior. So as we get more granular, we're going to discover different alternatives. What happens when we allocate directly to a component is the component doesn't have alternative behaviors. It doesn't have a bunch of different ways to perform a high-level behavior. It performs a high-level behavior in the way that it was created to perform it. So it has a behavior that's integrated. Now what that means is that this component is now imposing the behavior back on the system design. So it's not that you skip behavior. It's a fallacy to say that you skip behavior by allocating your requirements to the components. What you're doing is jumping to solution, which means that the behavior of the solution is imposed on the design, and from a creativity standpoint, that's costing you alternatives. So we're losing choices, and we know that the more choices we have, the higher quality solution that we are able to ultimately achieve, and the fewer choices, the lower the quality. The next creativity killer is getting too granular too quickly. Now I know we could never accuse those of us in the systems engineering world of getting into the weeds too quickly. We have a tendency to get into the weeds. For instance, often when I give a webinar or a class and talk about general principles, I'll get people coming back and saying, well, that was too general. You should have been more specific. I wanted to hear more detail about particular techniques. And the reason why, when I talk about principles, I talk about them is because when you make mistakes at the principle level, it causes things that can't be recovered at the granular level. So you cause yourself problems that you can't solve from down in the weeds. So what kinds of things could this cause us if we get too granular as we go through this process? Well, when we begin at a high level and we take a look at the alternatives, we get a broader view. So somebody positioned at Q for question at this point is looking at 3 alternatives in this example. So you could go down any one of these paths and you could make choices as you go down the path as to which way you're going to go next. But instead of making choices in the context of design, let's say we decided to go to that choice, which is pretty granular. So we're going to make that particular choice as a way of working ourselves to solution. We're going to get into the weeds. We're going to get granular. Well, what do we lose when we make that choice? We lose everything that's down the paths that we now can't go down, because in order to get to our choice, you have to follow the path that leads to it. So you no longer have the path open to go to any of these others. So you wind up losing all these alternatives, and you impoverish your ultimate solution by doing that. Now, here's a caveat. We do have constraints. Sometimes we have choices imposed on us, and those come in the form of constraints. For instance, when NASA was going to repair the Hubble telescope and repair the focus problems, one of the things that they realized was that in the time the Hubble had been aloft, camera technology had advanced. So it was clear that the smart thing to do would be to go ahead and update the camera on board the Hubble so that it not only would be refocused, but it would have the advantages of the updated camera technology. But in order to put the camera up there, there was a place where it needed to bolt in place, and there were connections that needed to be made and interfaces that had to be made in particular ways. So they weren't free to redesign the whole interface and the whole structure for the camera. So they were constrained in their choices. They didn't have a wide open field. That's a fact of life for all of us every day as we work with systems engineering problems. But while we deal with the constraints that we have, we don't need to go around creating additional constraints, effectively creating those additional constraints by making choices that are too granular. So what are the challenges as we begin to look at the creative process? The biggest challenge, the first challenge, is that we have to change our way of thinking. So we need to open our thinking to the divergent and convergent processes. Principally for technical people, that generally means learn divergent techniques and then discipline ourselves to stick to the divergent path and to use the techniques. There's some pretty amazing stuff out there. If you avail yourself of the Thinker's Toolkit and Thinker Toys resources that I have on the slide at the end of the presentation, you'll find that there are some very interesting options out there, and some that are very, very effective. One of the things that we know about the creative process is that, and this is recognized all the way back to the Italian philosopher Pareto, who pointed out to us that as it gets restated, an idea is nothing more or less than a new combination of old elements. that's how it's framed up in a book that I also have referenced for you by James Webb Young, called A Technique for Producing Ideas. And I can't say enough about that book. It's a book that was written in the 40s, and it was written by an advertising executive, but it's a tremendous book on the creative process and producing activities, or producing ideas rather. And it has a lot to say to us. But he points out that Pareto told us that what we're really doing when we come up with an idea is taking existing elements and combining them in new ways. And therefore, he says, the capacity to bring old elements into new combinations depends largely on the ability to see relationships. In other words, this really is right down our alley. We don't necessarily do this a lot, and we should discipline ourselves to do it more, but systems engineers are among the people in the world best positioned to be creative because we're trained to think in terms of relationships. Relationships are the key for us. So we tend to hold elements in relationship and understand that process. And that's what Jung says is the key to the creative process. The second challenge is to serve the divergent process, intentionally serve it. What does that mean? Well, our current tools and methods are set up to serve the late choice process and the refining process. So if you take a typical systems engineering tool and apply it, it's set up so that what you're doing is you're getting to the point where you have one or maybe two or three different kinds of choices, and you're going to down select from those and then refine your choice down to the ultimate implementation. So we have tools that serve that process, we have methods that serve that process, we focus on that process, and we do some of our best thinking along those lines. But we need to, if we're going to be more creative and improve the quality of our solutions, we need to learn to serve the divergent phase as well. So we need to serve that part of the process where you create choices. And what does that mean? Well, there's an interesting webinar which I've provided a reference to in the resource slide. It's actually a TED Talk by a guy named Tom Wujek, and it's entitled "So You Want to Make Toast," or "So You Have a Wicked Problem. First, Tell Me How You Make Toast." And he consults with people who are trying to solve complex, wicked problems, and he does it by having them describe how they make toast. And he begins by having everybody in the group independently draw how they make toast. And it's interesting, he points out that there are lots of different drawings for that process. It probably as many different drawings as there are people making them. But they all have nodes and lines. We all think in terms of nodes and lines, and that's certainly familiar to us in the systems engineering world. But the next thing that he does is he says, okay, let's instead of drawing on a piece of paper, everybody make a picture of the way you make toast and use sticky notes as your nodes. So they arrange sticky notes to show how they make toast. And he talks about, goes into some detail about how those drawings are improved, but you get a better picture out of that process. And he points out that the reason is using the sticky notes facilitates their ability to be iterative. So they're able to look at the sticky note arrangement, and where once you kind of get something drawn on paper, then it's pretty messy to try to change it, but there's no problem at all with changing sticky notes around. So it becomes an easy process to iterate on. And then he says, as the third step, he says, okay, now let's do it in groups. Groups come up with pictures of how to make toast. And they come up with much better pictures through their collaboration. So the characteristics of helping that creative process along would be to have some kind of an assistance, a tool, a method, and whatever it is, it needs to be accessible, it needs to be iterative and collaborative. And then lastly, if we were going to be really effective, what we want to do is we want to pass these ideas that we develop through and into the down select process. So it ideally would link up to the down select process and allow us to evaluate and make choices out of the menu that we create. But in creating a great number of choices, you're not going to invest a good deal of time, so it doesn't need to be overly complex. It needs to be accessible. It needs to allow for iteration and collaboration. And then you need to be able to link it up to the second part of your process, to the convergent part. The third challenge is that we need to get better at understanding the problem. Remember, we said this was very important, and this understanding sets the stage. So why is that important? Russell Acuff, if you're not familiar with him, you need to go on YouTube and search for him and be prepared. He's entertaining and insightful as well. He was a professor at the Wharton School and was very active and instrumental in the systems thinking world. He says we fail more often because we solve the wrong problem than because we get the wrong solution to the right problem. We have to understand the problem. We have to know what it is. We have to recognize it. So what does that mean for us? It means that as we resource this whole process, we need to figure out a way to resource our understanding of the problem. So we need to get all the way back to the beginning and provide resources, tools, and methodology. Some of those resources already exist. We're already able to resource the understanding of the problem. Let's think for a minute. Every time you have a system design, you're dealing really with three systems. The one that we're used to and the one that we typically focus on, and rightly so, is the system of interest. So in this case, let's say we're designing a new train to operate in a subway. So here we have a system of interest, and we know that we're designing that train. We don't really typically lose sight of it. We almost always lose sight of the second system, and that's the system that we use to design the train with. Very often we just kind of allow that to happen. We don't give much thinking to the process and the team and the composition of the system that we use to design. But the one that we're interested in here, which is sometimes forgotten, is the context system. Why is that important? Because the system of interest is going to go live in the context solution. The problem lives in the context solution. So we need to be aware of it. We should all be aware in the railroad sense of the context system. The context system last week was the curve and the track. The solution, the system that was operating in that context, was the train. The train was capable of going much faster than the track design was designed to handle. So you need to be aware of the context system and prepared to deal with the context system. Now, they probably, no doubt, were aware because the speed limit on that particular curve was way lower than the train, but whatever system was in place to prevent that either was not operational or wasn't in place at that particular point. And that's a matter of understanding the context. James Martin, a number of years ago, wrote a very, very interesting and telling article called "The Seven Samurai of Systems Engineering," and you can find that online. If you Google that, you can find that in PDF version. Everybody should read that article. His seven samurai are seven different systems instead of the three here, but what he's done is break down these three into different systems and considered it over time as you move from problem to solution. But understanding that is a challenge for us. Now, how could we resource that? We ought to be modeling the context system, or at least as much of the context system as is necessary to understand where the system of interest is going to fit, how it's going to interface, how it's going to interact, and how it's going to play in the context. So we ought to be applying our methodology and our tools to modeling the context as well as modeling the system of interest. Well, I hope you have enjoyed this discussion, and I will entertain your questions. These are the resources, and this is only the tip of the iceberg in terms of what these resources are. These are standard fare in the facilitator world, in the soft skills world. I kid my engineering buddies, and I'm not an engineer myself, I kid them about the soft skills designation. I was taught, of course, by soft skills practitioners that soft skills is the name technical people give to problems that are too difficult to be solved with their tools and methods. But the soft skill folks have used these and numbers of other tools, but these are particularly good. The first one is a technique for producing ideas. That's a little book that you can get on Amazon. The price is really, really low. It's available in Kindle version for under $3. Probably a function of the fact that it was written so long ago. It's an older book. It's just a short little book, can easily be read in one evening, but it ought to be required reading for anybody engaged in the creative process. And all engineers are engaged in the creative process. The second book is Thinker Toys. That's a book of techniques and approaches, and it's just a rich ground for resourcing your creative process. The same thing is true for the Thinker's Toolkit, a fascinating resource. Those are both available. And then I would recommend that everybody take the time. It's not a very long presentation, but look at the TED Talk, Got a Wicked Problem? First Tell Me How You Make Toast with Tom Wujak. I think it's interesting and insightful and has a lot to say about this particular topic. So with that, I'm at the end of my prepared presentation, and I'm ready to take questions. So if you have any, be happy to answer.
Thank you so much, Zane. And for anyone who needs to leave now, there will be a survey that opens up on your screen, and we would really appreciate if you would fill that out for us. I know sometimes time is tight. And let's see. So we've got a question from Scott, and Scott would like to know, when is the best opportunity to engage in divergent thinking? I think he's looking for some timing.
Well, the best opportunity to engage in divergent thinking is right at the beginning, before you have formed a hypothesis or a picture of what you think a solution might be. If you can create as many possibilities before you begin to turn naturally toward honing in on a solution, the earlier the better.
Okay, great, thank you. We've got another one here from Emily, and she would like to know, how can we best understand the problem? So where would we start?
Well, understanding the problem really comes with understanding the context for the problem. it's interesting because James Young gets into this in his book on producing ideas, but he talks about the two kinds of knowledge that we need to resource our understanding of problems and solutions. And he says one is we need domain knowledge. And so we begin to understand the problem by understanding the domain itself. And he said then the second area is a general area, an understanding of the rest of the world that we ought to. The best problem solvers are curious people who constantly feed their knowledge of the world. So it was important, for instance, for Gutenberg to have knowledge of some of the technologies involved in the printing world, but one of his major innovations was the screw-type press, and that had never been involved in printing. It was involved in squeezing the juice out of grapes and other fruits to produce the juices and ultimately to produce wine or juice for fermentation into wine. But it was his knowledge of that agrarian tool that he was able to draw in and combine with the problem that he faced in printing. So that really becomes the basis for our understanding of the problem and our understanding of potential solutions is our understanding of the domain, the specific domain of the problem, the context system, as well as understanding the broader domain of the world.
Okay, I've got a question from Stephen. He would like to know, do you think that it would be appropriate to model the context first or last?
I would actually model the context first. And in the world of procurements where we're producing RFPs, I think it would be really interesting for the folks who wanted to issue the RFP to model the context and to take a look at the context for the problem, and make that available in some way in the ultimate RFP that's issued, because then you could show the problem space. And James Martin has an interesting discussion of the problem and the way that it operates within the context and talks about some of the things that you need in order to understand the problem. But if you understood that prior to the procurement, it would be great. Failing that, I would think that you would need to model the context in relevant part before you begin your response to the procurement.
All right, let's see, we've got time for 2 more questions. So the first one here is from Robert, and he asks, how do you quell the resistance from the so-called subject matter experts who resist these creative engineering approaches? That's a big one. We get that one a lot.
Oh yeah, and it's a sea change in thinking, and the lots of times, and the reason that I even brought up the soft skills thing was that's the avenue that the criticism rides in on. You know, oh yeah, you're going to do this touchy-feely, this kind of stuff. But it's a matter, I think, of convincing them that they can broaden their thinking and improve their own solutions using their subject matter expertise. And I've actually seen it work, drawing together subject matter experts and appealing to their expertise and inviting them to throw off constraints and to expand their knowledge. It's sort of like some people will tell you, if you want to do something in the medical world, that if you're not a doctor, then doctors are not going to listen to you. And so sometimes you have to do it by allowing them to engage in their own creative process as opposed to directly suggesting solutions to them. But it's a matter of changing people's thinking, and it's not easy.
It definitely isn't. Our last question today is from Jeremiah, and the question is, how can someone working under duress and tight deadlines be creative as a systems engineer without being subjective and out of context?
Well, you know, one of the most interesting things about creativity, Jeremiah, is, and I can't remember whether it's in Thinker Toys or the toolkit, but one of the ways to heighten creativity is to introduce constraints. And there's a good deal of neuroscience research that says when you impose a constraint, and what they propose is like artificially limiting yourself in some way and then trying to figure out ways around the limitation. How am I going to cope with this, with the limitation? But my fundamental advice would be that you need to avail yourself of knowledge of the tools, knowledge of the processes, and practice, 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 practice. If you have to take the instruction manual to the golf course with you and tee the ball up and figure out what page tells you which club to use, etc., it's going to be difficult. So the best possible antidote for the time constraints and the ability to do it under pressure is practice. And this, incidentally, these techniques are not limited to the office, so they work in your private life as well. My dad, who had 2 liver transplants and a peripheral neuropathy that came from that, lost the fine motor skills in his right hand. And before he got sick, he was restoring an old truck, and when he got better, he went back to restoring the old truck. I went over one afternoon, and he was putting the screws into the straps that held the bed together in the back. So he had all these wood screws to put in, one every 6 inches in each of 8 straps across the bed. And he had a choice. He could either hold the screwdriver in his left hand, where he had good fine motor skills, in which case he couldn't hold the screw with his right, or he could hold the screw with his left hand, and then he couldn't manipulate the screwdriver. So he had taken an index card, and he was punching the screws through the index card, which he could grasp in his right hand without the fine motor skills, position the screw over the hole, and then use his left hand to tighten the screw down, and then rip the index card off and finish tightening the screw and move on. So, definitely a use of these kinds of techniques and problem solving. And if you'll practice and practice in your daily life as well as your professional life, you'll get better. And when you get better, you get faster.
Thank you so much, Zane. Thank you so much to all the questions. If you think of any additional questions that you did not get a chance to ask today, I believe the contact information, do you have that up, Zane?
Yes.
Is on your screen, so you can go ahead and reach out to Zane, or you can make comments on Vitech's LinkedIn group, and we will get those over to the appropriate people to get answers for you. You can also check out our forum, which is at community.vitechcorp.com. And thank you so much for attending today's webinar. Please keep an eye on your inbox for your next webinar invitation. We are going to have a customer-exclusive webinar invitation coming out soon in early June. And you can also stay up to date on all of our upcoming webinars by visiting our webinar calendar, which is on our website. And I will get a link out to it. That will come in your email. I'll send it in the chat window right now, but it will disappear when we end the webinar. And again, if you can get a chance to fill out that survey, we'd really appreciate it. And thank you so much to everybody, and have a wonderful day.